Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied about how can we name the IUPAC nomenclature for an alkane that has been given to us or that has been provided to us. So now we are going to draw the structural formula of the IUPAC name that has been provided to us for an alkene. So let us know how can we draw that. So starting with the first one, so this is the first molecule that they have provided the IUPAC nomenclature of an alkane and of which we have to draw the structural formula. So how can we draw? So there are few steps that we have to make in concern and then only we could be able to draw the correct structural formula of the alkene that has been provided to us. That is the IUPAC name of the alkene that has been provided to us. So in this case, how can we draw? So the name is 2-ethyl-but-1-ene. So the main thing that we have to consider is the parent name, and the parent name of the alkene is basically that is but-1-ene. So the name itself suggests that butene is the one which will have basically 4 carbon atoms. So that's the reason that we will draw 4 carbon atoms in this way. These are the 4 carbon atoms that we have initiated and we have drawn, and now we will initiate with the numbers, but we can number it from any side, that is from this to from left to right or right to left. So let me name this as carbon number 1, 2, 3 and 4. So while viewing the parent name of the alkene, what I am getting to do is the name is but-1-ene. This indicates that this number indicates that the double bond starts from the carbon number 1. So that's the reason we could write this as in this manner. We could draw this in this manner, and as you could see that the carbon-carbon double bond is starting from carbon number 1. So this is the skeleton of the carbon itself, but I have not fulfilled the hydrogen. So let us fulfill the hydrogen afterwards, but this is the one that we have drawn right now, that is for the parent alkene. But talking about is there any other substituents or is there any branching that has been attached to this parent chain? Yes, and that is nothing but ethyl group. This ethyl group that is being used as a prefix when a IUPAC nomenclature of the alkene has been provided which indicates that the prefix is basically the branching, so or branching which has been attached to the parent chain. So this group, that is the ethyl group, is been present, and ethyl group can be written as, I would write over here as C2H5. But this C2H5 or this ethyl group is been attached on the second carbon atom. This number indicates the position of the substituent or the position of the group that has been attached to the parent chain, while this number indicates the carbon-carbon double bond. So there are the two differences that we have discussed in the IUPAC nomenclature of the structure that we have did in our previous lecture. So this indicates that this indicates this second position or the second carbon atom to which the ethyl group has been attached. So I will attach the ethyl group, I would attach over here also like C2H5. So this has been attached, we have attached over here, and now this is the structure of the name. But is it complete? No, it is not complete, because alkenes are hydrocarbons and here we have not fulfilled the hydrogen, and moreover we could see that the carbon valency is not been fulfilled. So that's the reason we are going to fulfill it. And how? See, if you look at this carbon atom has only 1 bond over here, making this to have only 1 valency, but carbon has actually 4 valency, and the rest of the 3 valency will be fulfilled by the hydrogen. So that's the reason we will fulfill it by hydrogen, like the term like CH3. Talking about this carbon atom has been attached to with 2 bonds, making it valency of 2 right now. But as you know that carbon has a valency of 4, so therefore there are 2 more valency that are been left, and that would be because of fulfilled because of the hydrogen. So therefore I would write it over here H2. And talking about this carbon atom is already fulfilled with its valency. That is the reason you could see that there are 4 bonds, that is 1 double bond and 2 single bond, making it to be 4 bonds. And talking about the first carbon atom, this carbon atom is been attached with a double bond to the another carbon atom, making it valency as 2, but carbon has a valency of 4. So anyway we have to fulfill the valency by substituting or by fulfilling the hydrogen atoms. So therefore this is how I have added CH2. So now this is the structure or the structural formula of the IUPAC name that is being provided to us. A very easy task to do this thing. So I hope you have understood this concept. So this is the main concept that we are going to apply on the various examples that we are going to talk about. So this is what we have maintained our that is the rule of IUPAC also. How? Let me tell you that. Suppose if you extend this C2H5, or we could write C2H5 as CH3 CH2, or in this manner if I would say like CH2 CH3. So the longest chain would be this one, but in terms of alkane. But in terms of alkene, it should consist of double bond. That's the reason the double bond is over here. And this is to be considered as the longest chain. I'm talking about this one. So in this case also, we have also learned about the IUPAC rules. So in every example, we'll try to discuss about the IUPAC rules, as well as we are going to draw the structure of the IUPAC name that has been provided to us of an alkene. So this was the first example. Let us try out the second one. So this is the second example of which we are going to draw the structural formula. So let us consider this as an example where we are going to draw the structural formula, and this says that it is 2,5 dimethyl hex 2ene. So how can we draw? Yes, we have to only focus on the, that is the parent chain or the parent carbon atom in this case, and the parent name of this is basically hex 2ene, which indicates that it is basically an hydrocarbon, which is basically unsaturated hydrocarbon, which consists of 6 carbon atoms in a straight continuous long chain that also consists of a carbon-carbon double bond. So we could write this structure as 1, 2, 3, 4, 5, 6. So 6 carbon atoms are in a straight chain, and that's the reason this indicates that this is the parent chain, or we could say the parent chain that consists of basically 6 carbon atoms. And talking about basically this is an alkene. And how did I got to know about this? Because it ends with the word or with the suffix ene, which is nothing but indicates that it is an alkene. So this alkene has a double bond, and the position of the double bond is over here. So in this name, the number between the two words, if I would see, this indicates the presence of carbon-carbon double bond, and moreover on the second carbon atom. So here I have not mentioned the number, but I could mention the number also, because numbering is a very main important thing that whenever we conclude the IUPAC nomenclature of the structure, or whenever we are drawing the structure of the IUPAC name of an alkane or of anyone. So the numbering is the main thing, and that should also be in sequence, and it should be either from left or right hand side when we are drawing the structural formula. So suppose in this case, if I have taken it from this side, suppose like 1, 2, 3, 4, 5, 6. This is a thing that I am just making you sure that you could take from any side, and but the thing is, you should follow the rules of the IUPAC, and that is the thing that we are going to observe. So in this case, basically we are saying that it is hex 2ene, indicating that the second bond, that's the second carbon atom, will have a carbon-carbon double bond that will be attached with the carbon that is the third carbon atom. So this is what I'm talking about. That is, the carbon-carbon double bond is between carbon number 2 and carbon number 3. Or we could also say in this manner that the double bond arises from the carbon number 2 to carbon number 3. So this is what we have did. So this is the hex 2ene, but it is not completed, because as we could see that the alkyl groups, or we could say that the substituents are also been attached to this parent chain of the carbon atom, and so that indicates that it has on the second position there we could see a substituent. So I would write it over here in this manner, that is on second position, and again on the fifth position I have a substituent, because this indicates that the position of the locants, or the I would say that the locants where the groups are been attached. So this indicates the position in which the second will have a branching, while the fifth will also have a branching over here. So this all are single bonded, even this is a single bonded, even this is a single bonded, and moreover we could see that a methyl group is been attached. But there is not only one methyl group, that are basically 2 methyl groups. This is how I got to know, because here I have seen it as dimethyl. So dimethyl means there are 2 basically methyl groups, and that are being attached at the carbon number 2nd and carbon number 5th respectively. So that's the reason I would write it over here, the methyl group, and methyl group is nothing but CH3 group, and that is attached to the second carbon atom as well as on the fifth carbon atom of the parent chain, and this is the methyl group that I have attached. So this is the thing that we have did, and this is how we have to draw the structure of the IUPAC name in a very convenient manner. And but this is not complete yet. The reason behind that is the hydrogens are not been fulfilled with their that is the carbon are not fulfilled with their hydrogens, and the valencies are also not fulfilled. So for that, what we have to do is, again, we have to use the theory of the valency of carbon atom, and that is 4. So in this case, it is only one bond that has been attached, so therefore the remaining 3 valency will be fulfilled by the hydrogen. So in this manner also we could draw in that perspective so as to get a perfect structure for the IUPAC nomenclature that has been provided to us. So now, talking about this carbon atom doesn't need any hydrogen to be attached. The reason behind that is it is already fulfilled by the 4 valencies or the 4 bond that you could see over here. And talking about this carbon atom, that is the third carbon atom, as you could see that 3 bonds are being attached to this by this. So that's the reason only 1 valence has been left that would be fulfilled by only 1 hydrogen. But talking about this carbon atom, this would be fulfilled with 2 hydrogen. Again, this carbon, it is having 3 bonds, so only 1 bond is left so as to complete the valency. So that's the reason CH and ultimately CH3. So this is what we have draw the structure of the second example, that is 2,5 dimethyl hex 2ene. And let us check whether we are following the IUPAC rules or not. Again, the same thing that we have did according to, we have selected the longest chain. Suppose in this case, suppose I am seeing a longest chain, and yes, and I will number it. So numbering can be left to right or right to left. So in this case, I have mentioned it from from right to left. And on the second position, I could see that is methyl group is present. Again, on the fifth position, methyl group is present. So this is the what I have mentioned, CH3 and CH3 over here, and that is it. And moreover important, that is on the second carbon atom and the third carbon atom, between these 2 carbon atoms, a double bond has been present. So now this is how we have looked about the carbon, a hydrocarbon consisting of 6 carbon, and which is nothing but an unsaturated alkene. So this is what we have. So now let us took another example, that is the third example, and let us try out how can we draw this one. So this is what we are taking an example, and for which we have to draw the structure. So again, the main thing that we have to always look out the parent name of the IUPAC nomenclature of the IUPAC name that has been provided to us of an alkene. Of an alkene or might be of an alkane, we have always to concern about the parent name of it. So this is the parent name which ends with the suffix, that is we could say it as penta 1,4 diene. So penta 1,4 diene itself indicates that it is the one which consists of 5 carbon atoms that have been in a continuous chain. So therefore we could write this as 1, 2, 3, 4, 5. So 5 carbon atoms are present in the parent chain, and talking about or in the continuous longest chain according to the IUPAC. And in this case, basically, let us number it first. After that, we will do the further thing. So first, second, third, fourth, fifth carbon atom have been present, and in this case I could see that at carbon number 1 and at carbon number 4 there is a presence of double bond, because this number which is between the 2 words of the parent alkene that has been present, that has been given to us, it represents the position of the carbon-carbon double bond. So therefore the position of the carbon-carbon double bond is at carbon number 1, from carbon number 1, and at carbon number 4, as we could see over here. And since 2 carbon-carbon double bonds are present, that's the reason here di is been present. So this di indicates there is presence of 2 carbon-carbon double bonds, and which is nothing but we have drawn over here. So now the work is not yet been done. We have to provide or we have to substitute the substituents that are being attached over here, that is the methyl groups. And how I got to know? First of all, let us see where the substituents are or where the branching is. The branching is at basically, I would call it as at second one. So this is the second carbon atom. So here a branching is. Then again at the third one, and at fourth one. So there, here it is branching, and what are being attached to this? So that is also a main concern thing. So on second, third, and fourth, basically 3 methyl groups. This tri indicates there are 3 methyl groups in the overall molecule that are been attached to the parent chain. So if this is the parent chain, and there we could see that the groups are been attached, and those groups are nothing but methyl groups. All the groups that are been attached in this name that we could see is the methyl group. So that's the reason we could write it as, on second carbon atom I could see a methyl group, that is CH3. Again on the third I could see a methyl group, I would write over here, and again on the fourth I would write over here. So this is how I have fulfilled the substituents or the branching. As we could see, the branching is also been mentioned over here by indicating one bond in each second, third and fourth. But now it is not been complete yet. We have to fulfill the hydrogen also. So how can we fulfill the hydrogen? Yes, just look at the valency of the carbon atom. So in this carbon atom, basically two bonds are being attached over here. So making this, again I will say, because we should not get confused while filling the hydrogen atoms. Some students get confused and they could add more hydrogens. So that would be invalid, and that wouldn't be the correct structure of the hydrogen. So again I would repeat the same thing, that carbon has a valency of 4. And that's the reason that the two bonds are been mentioned over here, and the two bonds would be satisfied by the hydrogen if they would be attached over here. So we could write it over here as CH2. Talking about this carbon atom is fulfilled. Why? Because as you could see that there are 4 bonds, that is 1, 2, 3, 4. 4 bonds are being present, and the carbon valency is also 4. So this is also been fulfilled. Talking about this third carbon atom has a valency of 3, as means the bond is been 3, as you could see over here, but the valency would be 4. So that would be fulfilled by hydrogen. So I would write over here. And talking about this carbon atom, this carbon atom also don't need any kind of hydrogen attachment, because it itself is satisfying its valency by forming 4 bonds. And talking about this carbon atom will be attached with 2 hydrogen atoms so as to complete its valency. So this is the structure of the name that has been provided to us. Very easy task. But again, let us see whether it is following that is IUPAC rules or not, just for an instance, because this would be kind of recap that we have did in our previous lecture. So suppose if this is the structure that we have, and suppose if we have to provide the IUPAC nomenclature of this one. So what we'll do is, the first thing is we'll select the longest chain. So this is, and yes, we'll select the longest chain in such a manner that it should contain carbon-carbon double bond. So that is the reason that we'll select a longest chain, that this is the longest chain that we have drawn, or we could take, and we will fill it with the numbers, that is 1, 2, or indicating the numbers of 2 carbon atom, 1, 2, 3, 4, 5. And on this thing, as we could see that on second position a methyl group is present, on third carbon atom again a methyl group, and fourth carbon is again a methyl group is present. So basically there are 3 methyl groups that are present over here, and that's the reason that we could write it, the position of the substituents. And let us see that where we could find out this substituents or this branching, that is at second, third and fourth, and all are the substituents, all are basically the methyl groups. So therefore we could write it as 2, 3, 4. 3 times methyl groups are being present in the that are being attached to the parent chain. So therefore making it to be called as 2, 3, 4 trimethyl. And the overall structure or overall the parent chain consists of 5 carbon atoms, basically indicating this to be known as pentane when it comes to an alkane. But this is not an alkane, this is an alkene, where I could see that the carbon-carbon double bond is starting from carbon number 1 and carbon number 4. So indicating the name is pentadiene, but the double bond are present at carbon number 1 and carbon number 4, making it to be called as more precisely as penta 1,4 diene. That is what we have written over here. So this is a very easy task that we have did, but yes, we have to just cross check whether we are following the same rule or not. But the similar thing that we have did in the first and or the second example, where we have got to know that the C2H5 was also been attached, and that was not under the longest chain, that was acting as a substituent, because according to the IUPAC nomenclature of an alkene. So that is the thing that we have to keep it concerned. So this is the third one that we have did, and let us move on to the next one, and a kind of next type of nomenclature where most possibly that we could get confused. So that's the reason we are trying more and more IUPAC nomenclature so as to draw the structure of that. So let us try this one. So again, the similar thing is we could draw it very easily from. The first thing is we have to just focus on the parent chain, and the parent chain is indicated in terms of alkene. It has been indicated at the last, or we could say at the suffix. So in this case I could see this is to be the parent chain, where could see as pentane or pentene basically. And when it comes to pentene, basically it consists of 5 carbon atoms. So therefore this is the 5 carbon atom. I would draw in a straight chain like 1, 2, 3, 4, 5. It has been done, but it is not an alkane. It is an alkene, means there is would be presence of carbon-carbon double bond. And this die, it indicates that there is not only one, but there are 2 carbon-carbon double bonds. And where? At carbon number 1 and at carbon number 4. So I cannot randomly name it as carbon number 1. So there should be a particular sequence, either from left hand side or either from the right hand side of the screen that we could see, or from the end as we could see for the carbon. So therefore this one would be carbon number 1, 2, 3, 4, 5. And I could see that as this name suggests, at carbon number 1 and carbon number 4 the double bond is being present, or from which the double bond starts over here. So I could write it over here as carbon number 1, and between carbon number 2 a double bond is been present, and carbon number 4 indicates this indicates that the carbon double bond starts from carbon number 4 and it ends with 5. Or we could say in this manner also that the double bond is present between carbon number 4 and carbon number 5. So this is the name, this is the number that indicates that in IUPAC nomenclature also we have studied that we'll number it first, and that will indicate basically the position of the carbon-carbon double bond. So here it is. So this work has been done, but it is not yet complete. We have to also focus on the substituents, and in this case the substituent is basically the methyl group, as we could see over here. And that methyl group is been attached to the second position. This indicates the position of the methyl group, or through or the position where the branch we could observe. So this is the thing that is on the second carbon atom. We could see this is single bond, but I have indicated with a reading so as you should not get confused, and we should focus on this thing so as our answer or the structure would be in a very proper way. So we could write it over here as methyl group, and methyl group is nothing but CH3. Almost work is done, and the thing that has been left is fulfilling the hydrogen atoms. So let us start from here. So I would fulfill it by H2. Here I will fulfill it by H, because again the theory of carbon valency, talking about this would be filled by H2. No need to fill with hydrogen because all are being satisfied by the bonds, or the valency has been satisfied. And talking about this one, this is H2 where we will fill. So this is a very easy structure that we have did, and because of this this kind of easy that we have did in our earlier examples also, that is 1, 2 or 3. So let us move on with the next one. So now this is a name that of which we have to draw the structure, and the same thing that we are going to do is focus on the suffix of this, and the suffix indicates it's hexatriene, or we could say it is a hexene. And hexene is the one which consists of 6 carbon atoms that are being present in a longest chain form. So that is the reason we will draw it this way. That is 1, 2, 3, 4, 5, 6. 6 carbon atoms are over here, and let us number it as carbon number 1, 2, 3, 4, 5, 6. And this number indicates the presence of carbon-carbon double bond, and the double bond starts from carbon number 2 and between carbon number 2 and carbon number 3. So therefore this will indicate that carbon number 2 and carbon number 3 consist of a double bond between them, and this is what it is. And the further thing is the substituent. As you could see, this is not only one substituent, but there are many substituents, as you could see over here. That is ethyl group and methyl group, and where they are been attached, that is the main thing. So ethyl group, or suppose the first thing that we have to do is where the branching starts. These numbers that are indicated before the alkyl groups are basically indicating the branching from on the parent chain. So this is the parent chain that we have, and on the branching, this 3 indicates that the branching is on the 3rd carbon atom, on the 5th also, again on the 5th. And what are being attached on that locates or at that carbon atom, let us consider. So this is the 3rd carbon, on the 3rd carbon atom basically ethyl group is present. So this is the 3rd, and I will attach with ethyl, that is C2H5. On the 5th, and again on the 5th, 2 methyl groups are being present. So therefore this would be methyl, and again this would be methyl. So my almost all the work has been done, but the hydrogen fulfill is been remaining. So let us focus on this one. This has a carbon, this carbon has only one bond, as I could see over here. So I will fulfill it by 3 hydrogen atoms so as to complete the valency. No hydrogen is been required for this carbon atoms because it is already satisfied with its valency. Talking about this, H2 will be there. No need for the hydrogen over here. 1 H, because it was earlier it was fulfilling with 3 bonds, and 1 bond will be for the hydrogen. And talking about here, 3 hydrogen will be fulfilled. So this is how we have draw the structure, and this is how we should draw the structure so as to get a perfect structure of the IUPAC nomenclature that has been provided to us. And talking, just let's just cross check that whether we are right or not. So now here we can cross check it. Suppose if the name is not been provided to us, and this is the structure that we have in concern, and for which we have to provide the IUPAC nomenclature. So this is the longest chain of the carbon atom, and we could consider that the carbon-carbon double bond should also be present in that. So this is the longest chain where we could see that the carbon-carbon double bond is also be present. And now the next thing that we have to do is we have to number it. So 1, 2, 3, 4, 5, 6. 6 carbon atoms are arranged in a straight chain or in a continuous chain. And in this case, on the third and fifth, and again on the fifth, we could see the branching, or we could see that the substituents that are been attached over here as C2H5 known as ethyl, CH3 known as methyl. So the third one has basically C2H5, that is ethyl group. And how can we name it? See, suppose if we have numbered from this manner, that is from here, that is 1, 2, 3, 4, then in this case basically the double bond would be far away from this end, but it is very much nearer to this end. That's the reason we have numbered it from 1 to 6 over here. And that's the reason that on third carbon atom ethyl group is present, and on fifth methyl group is present, and third and fifth, and again on fifth methyl group is present. So therefore we could name this as 3-ethyl. And the word 3-ethyl, it doesn't depends on the number, or doesn't depends on the locate. It is main concerned with the alphabetical order. That's the reason ethyl has been came first. It is not only because of the at third position ethyl has been present, it is because of the alphabetical order. That's the reason we prefer ethyl first, regardless of their number or regardless to where it has been attached to. So now ethyl has been attached on the third carbon atom, and that's the reason we write 3 before ethyl. And then on fifth we could see methyl, and again on fifth we could see methyl. So merging it to be known as 5,5 dimethyl, and the overall straight chain or the parent chain consists of 6 carbon atoms, that is known as hexane in terms of alkane. But we could see that the carbon-carbon double bond is also present between carbon number 2 and carbon number 3, making it to be called as hex-2-ene. So this is how we could cross check it. So a very easy task to for this structural formula, to draw the structural formula of the IUPAC nomenclature that has been provided to us. Now let us move on to the last one, that is this one, and for which we have to draw the structural formula. Again the theory will be the same, or the concept will be the same, that is to select the prefix one which indicates the parent chain, and in this case it is nothing but hexatriene. So hexa indicates basically 6 carbon atoms, so therefore we will write over here as 6 carbon atoms. 1, 2, 3, 4, 5, 6 carbon atoms are over here, and we'll name it, we'll number it basically 1, 2, 3, 4, 5, 6. And since it is an alkene, because this is how we have got to know, because it ends with the word ene, which indicates that it is an alkene, that is there should be carbon-carbon double bond, at least one. But before that I could see tri indicates that there are 3 carbon-carbon double bond in this molecule, and moreover in a straight chain. And talking about, and where are those 3 double bonds? They are present at carbon number 1, 2 and 3. So this is the position of the carbon-carbon double bond, which is carbon number 1 between carbon number 1 and 2, 2 which indicates between carbon number 2 and 3, and 3 which indicates between carbon number 3 and 4, or which also we could say in that manner that the double bond emerges from the carbon number 3 to carbon number 4. So this is how we have just draw the data from what we have got, and we have made the structure in this manner regarding the suffix. And now talking about the groups that are been attached over in this parent chain, and that is nothing but methyl group. And the methyl group is not only one, there are basically two methyl groups, because this dimethyl, it indicates because there are two methyl groups, and where they are attached at carbon number 5th and again at carbon number 5th, making to be known as CH3 as a methyl group. So almost the work is done, and the thing is we have to fulfill the valency. Again here it would be CH3, no need of hydrogen because all the valency are been fulfilled. Here only one hydrogen will be there, nothing is been required over here, nothing hydrogen to be attached over here, no even hydrogen is to be attached over here, because all the carbon atoms, that is these two carbon atoms, are been fulfilled. And talking about this carbon atom would be fulfilled by the two hydrogen atoms, so as to balance or so as to fulfill its valency of carbon atom. So this is how we have did the structural formula of the name, that is 5,5 dimethyl hexa 1,2,3 triene. So this is how we have did. Again, cross checking would be the simple thing. Suppose if you don't have this as a IUPAC name, and for which you have to give the IUPAC nomenclature of this one, so set the longest chain which consists of carbon-carbon double bond, and here we could see that there are 3 carbon-carbon double bonds at carbon number 1, 2 and 3. So we will name it as so this would be basically hexa 1,2,3 triene. But the methyl groups or the substituents are also been attached on carbon number 5th, making to be making us to give a name in this manner, that is 5,5 dimethyl that is hexa 1,2,3 triene. A very easy concept that we have did, but this was very much essential for us to understand that even this is very important for us to draw the structure of the IUPAC nomenclature that has been provided to us. So thank you friends for watching this video. I hope you have liked this video and you have understood this video very much clearly. So share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.